everyone, this is Kalpana here. In this video we are going to solve a differential equation from higher order linear differential equations. So let's get going. Problem: solve d square plus d plus 1 into y equals to x cube. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so our order will be 2, and the highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y plus dy plus 1 into y equals to x cube. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write the differential equation as d square y by dx square plus write dy as dy by dx plus y equals to x cube. Here d square y by dx square is the highest derivative, so order will be 2, and the highest power of the highest derivative is a degree. Degree is 1, right? Now coming to the problem. Given differential equation, d square plus d plus 1 into y equals to x cube, which is in operator form. F of d into y equals to q, where f of d equals to d square plus d plus 1 and q equals to x cube. Now we need to find the general solution to our problem, which is given by y equals to yc plus yp. Here yc is a complementary function, yp is particular integral. We'll find yc using the roots of auxiliary equation of homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0, we'll get f of d into y equals to 0, which is a homogeneous equation of the given non-homogeneous equation. And yp is we can find yp using 1 by f of d into q. Right? Here we have q of x power k form. So we'll find yp using 1 by f of d into x power k. See, here you're having q. So d power k of q will be 0 from k equals to 4, 5 and so on. Right? We'll get the values of derivatives of x cube till you'll get the value of d square, this is cube, right? And d cube, and from d power 4 you'll get zeros. Okay, we'll see it later. You'll get derivatives till k equals to 3. Okay, for d power k x cube. Just compare x cube with x power k, then till k equals to 3 you'll get derivatives of x cube. Fine. Now firstly let's find the complementary function using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square plus d plus 1. Let's replace differential operator by m, then we'll get f of m equals to m square plus m plus 1. Then our auxiliary equation becomes m square plus m plus 1 equals to 0. Now let's compare this with quadratic equation am square plus bm plus c equals to 0 and use quadratic formula to find the roots. M equals to minus b plus or minus square root of b square minus 4ac by 2a. Compare these two equations and we'll get a equals to 1. Quotient of a is 1. Sorry, quotient of m square is a equals to 1. By comparing the quotient of m, we'll get b equals to 1 and c equals to 1. Then m equals to minus b plus or minus square root of b square minus 4ac by 2a gives minus b. For b equals to 1 plus or minus square root of b square 1 square minus 4 into 1 by 2 into 1, which is equals to minus 1 plus or minus square root of 1 minus 4 by 2, which is equals to minus 1 plus or minus square root of minus 3 by 2, which is equals to minus 1 plus or minus, you can write this minus 3 as minus 1 into 3 by 2. Now split square root of minus 1 into 3 as square root of minus 1 into square root of 3 by 2, which is equals to minus 1 plus or minus. We know that square root of minus 1 is I, then you can write it as minus, okay, plus or minus I into root 3 by 2, which is equals to minus 1 by 2 plus or minus I into root 3 by 2. Right? Then m equals to minus 1 by 2 plus or minus I into root 3 by 2 are the roots of our auxiliary equation f of m equals to 0, which are a pair of complex conjugate. Which are a pair of complex conjugate. We know that if a plus ib is a complex number, its conjugate is a minus ib. If a minus ib is a complex number, its conjugate is a plus ib. So we call a plus or minus ib as complex conjugate roots, right? If m equals to a plus or minus ib, then we can write yc as e power ax into c1 cos bx plus c2 sin bx. Now let's write our complementary function. For m equals to minus 1 by 2 plus or minus I into root 3 by 2. Our YC looks like e power minus 1 by 2 into x into c1 cos root 3 by 2 into x plus c2 sin root 3 by 2 into x, which is equals to e power minus x by 2 into c1 cos x root 3 by 2 plus c2 sin x root 3 by 2. Now let's find yp, particular integral. We'll find particular integral using yp equals to 1 by f of d into q. We have f of d, d square plus d plus 1 and q, x cube. Now we can just take the first two terms as one term and one as another term, and we can write the denominator as 1 plus d square plus d, which is of some 1 plus x form, right? Then we can write it as 1 plus d square plus d whole inverse, okay? 1 by 1 plus d square plus d can be written as 1 plus d square plus d whole inverse into x cube. Now we can expand this using binomial theorem. 1 plus x whole inverse, which is equals to 1 minus x plus x square minus x cube plus x power 4 minus x power 5 plus so on. Firstly, let's find derivatives of x cube. As I said earlier, d power k of x cube is 0 from k equals to 4, 5 and so on. So let's see how we are going to get this. Firstly, let's find derivatives of x cube. Derivative of x cube is 3x square. Now let's find d square of x cube, which is derivative of x cube. We have the value of derivative of x cube, which is 3x square, right? This is equals to 3 into derivative of x square, which is 3 into derivative of x square with respect to x is 2x. Then we'll get 6x. Now let's find d cube of x cube, which is given by d's derivative of d square of x cube. We have the value of d square of x cube, which is 6x. Then we can write it as 6 into derivative of x. We know the value of derivative of x is 1. So we'll get 6. Now let's find d power 4 of x cube. Is given by d derivative of d cube of x cube. We have the value of d cube of x cube, which is 6. And we know that derivative of a constant with respect to x is 0. Right? So we got d power 4 of x cube is 0. Likewise, we'll get the higher powers from here, 0. Right? And so on. So from this we can say that in general, d power k of x cube is 0 from k equals to or for k equals to 4, 5, 6 and so on. Right? So you have cube here. That means you have q equals to x power cube. Just compare x cube with x power k. Then you'll get the derivatives of q till k equals to 3. Okay? Till k equals to 3, you'll get the derivatives of x cube. And from here, you'll get zeros. Fine. Now, let's expand this. Firstly, we'll do some rough work before applying in the problem. I'm writing the same thing. Right. Now let's expand 1 plus d square plus d whole inverse is equals to 1 minus c. We know that the terms, higher terms from d power 4 gets 0. So we can eliminate from x power 4. Okay. And let's try for the first 4 terms. Minus x. Just compare this 1 plus d square plus d with 1 plus x. Then for x equals to d square plus 1, we can apply this formula. 1 minus x plus x square minus x cube is equals to 1 minus x d square plus d plus expand this d square whole square plus d square plus 2 into d square into d minus, here we need to use a plus b whole cube formula. A cube plus b cube plus 3ab into a plus b. From this we'll get d square whole cube plus d cube plus 3 into d square into d square plus d, right? Which is equals to 1 minus of d square plus d plus d square whole square is d square into d square, d power 2 plus 2 is d power 4. So d square whole square is d power 4 plus d square plus 2 into d square into d is d power 2 plus 1 d cube minus of d square whole cube is d power 6 plus d cube plus 3 into d square into d is d cube. 3d cube into d square plus d. Right? This becomes 1 minus of d cube. Sorry, this is d square, okay? D square plus d plus d power 4 minus, plus d square plus 2d cube minus of d power 6 plus d cube plus 3d cube into d square is 3. D cube into d square is d power 3 plus 2, which is d power 5. You'll get 3d power 5 plus into plus 3d cube into d. 3d cube into d is d power 3 plus 1, which is d power 4. You'll get 3d power 4. Right? So, we know that the higher powers from d power 4 will get 0. So, we'll eliminate, or we can eliminate d power 4, d power 5 terms from 4, 5, 6 and all. Okay. So, from x cube, that is d square plus d whole cube, you'll get only one term. Right? Fine. Now coming to the problem. You can write it as 1 minus, here we are going to expand this using 1 plus x whole inverse, right? D square plus d square plus d whole square minus d square plus d whole cube into x cube. This is a rough work, okay? We'll be using in the problem is equals to 1 minus of d square plus d, and expansion of d square plus d whole square is d power 4 plus d square plus 2d cube minus expansion of d square plus d whole cube is this one, d power 6 plus d cube plus 3d power 5 plus 3d power 4 into x cube. Since we know that d power k of x cube is 0 for k equals to 4, 5, 6 and so on. So neglect higher powers from d power 4, d power 5, d power 6 and so on. Okay. So we are going to neglect d power 4 and d power 6, d power 5, d power 4. This becomes 1 minus of d square plus d square plus 2d cube minus of d cube into x cube. Okay, I'm not removing brackets before confirmation. You may get confused, right? Now we can remove brackets. Minus d square minus into plus minus d plus d square plus into plus plus 2d cube minus d cube into x cube. Now we'll get here minus d square plus d square gets cancelled. Okay, and from plus 2d cube minus d cube we'll get 1d cube. We'll get 1 minus d, and from plus d cube minus d cube we'll get 1 plus d cube into x cube. This is equals to 1 into x cube minus derivative of x cube plus d cube of x cube, which is equals to x cube minus derivative of x cube is 3x square plus d cube of x cube is 6. Therefore, yp equals to x cube minus 3x square plus 6. Now let's write general solution. The general solution is given by y equals to yc plus yp. Then we'll get y equals to yc, we have e power minus x by 2 into c1 cos x root 3 by 2 plus c2 sin x root 3 by 2, right, plus yp x cube minus 3x square plus 6, which is the required solution. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.